December 26, 1944, the Ardennes Forest, Belgium. SS Obersturmbannführer Jochen Peiper stood in the cupola of his Panther Ossifa G tank, watching the road ahead through the pre-dawn darkness. His Kampfgruppe, a reinforced battle group of approximately 4,800 men and 600 vehicles, including 72 tanks, had penetrated 25 miles into American lines in just 2 days. The offensive, Hitler's desperate gamble to split the Allied armies and capture Antwerp, had achieved complete tactical surprise. Peiper's Tigers and Panthers had torn through American positions with contemptuous ease. His men reported that American M4 Sherman tanks, when encountered, typically fled or burned after a single hit from German 80mm guns. Yet, as dawn broke on December 26th, something unprecedented occurred. From the hills north of Stoumont, Peiper's forward observers reported movement. Not a handful of retreating American tanks, but columns of them. Shermans, dozens of them approaching from 3 directions. Then more reports came in from the flanks. More Shermans. Then from the rear. The Americans weren't retreating. They were surrounding him. By noon, Peiper's Kampfgruppe faced an estimated 150 American M4 Sherman tanks from the 2nd and 3rd Armored Divisions. His own force, despite its technical superiority, numbered only 39 operational tanks after 2 days of combat and mechanical breakdowns. The Germans were outnumbered nearly 4-1. Peiper, one of Germany's most decorated tank commanders with a reputation for aggressive warfare, made a decision that would have been unthinkable to German armor doctrine just 2 years earlier. He ordered a withdrawal. The retreat of Kampfgruppe Peiper represented more than a tactical setback in the Battle of the Bulge. It symbolized the ultimate validation of an American industrial philosophy that German tank commanders had mocked since the first M4. Shermans appeared in North Africa in 1942. The philosophy was simple, almost absurdly so. Build adequate tanks, build them quickly, and build so many that numerical superiority overwhelms tactical inferiority. The Germans called it crude. They called it unsophisticated. They called it typical American waste and ignorance of proper armor doctrine. What they failed to understand until it was far too late was that wars are not won by individual tank duels, but by the cumulative mathematics of industrial production. And in that contest, America possessed advantages so overwhelming that German technical superiority became strategically irrelevant. The story of how American industry crushed German armor excellence begins not on European battlefields, but in the planning offices of the U.S. Army Ordnance Department in the spring of 1940. Major General Charles M. Wesson, Chief of Ordnance, faced a problem that kept him awake at night. The German Blitzkrieg had just overwhelmed France in 6 weeks. German panzer divisions had demonstrated that massed armor formations could achieve operational breakthroughs that traditional infantry forces could never match. The United States Army in 1940 possessed approximately 400 tanks. The majority were obsolete light tanks weighing less than 15 tons with armor so thin that German anti-tank rifles could penetrate them. The U.S. had no medium tanks in production, no heavy tanks, no tank divisions, no doctrine for armored warfare, no manufacturing infrastructure capable of producing tanks at scale. Germany, by comparison, fielded approximately 3,500 tanks in June 1940. While many were light Panzer I and II models, the Germans possessed combat-proven designs, trained crews, and most importantly, operational experience using massed armor formations. If the United States entered the war, American forces would face an enemy with overwhelming armor superiority and years of combat experience. General Wesson convened a series of meetings in July 1940 that would determine American tank philosophy for the entire war. The attendees included representatives from Aberdeen Proving Ground, the Armored Force Board, and industrial consultants from automotive companies. The transcript of these meetings, declassified in 1975, reveals a fundamental debate about American tank design philosophy. Colonel James K. Christmas, representing Aberdeen Proving Ground's Armor Testing Division, argued for quality over quantity. His position, supported by several military officers with traditional artillery backgrounds, emphasized developing tanks that could compete individually with German designs. This meant heavier armor, more powerful guns, sophisticated engineering. Christmas estimated that such a design would require 18 to 24 months of development and would limit production to perhaps 500 units annually. Given American manufacturing capacity at the time, the counter-argument came from an unexpected source. William Knudsen, president of General Motors and newly appointed director of industrial production for the War Department, had toured American automotive plants specifically to assess tank production potential. His perspective, documented in a confidential memo to General Wesson dated August 3, 1940, challenged every assumption about American armor philosophy. Knudsen's memo, preserved in the National Archives, outlined what would become American armor doctrine. The automotive industry can build tanks. We build complex machinery with precision tolerances at high volume every day. But we cannot build complex, highly specialized tanks in the quantities needed to fight a modern war. What we can build are standardized tanks using proven automotive components. If the Army will accept mechanical simplicity over technical sophistication, American industry can produce tanks in quantities that will overwhelm any enemy through sheer numerical superiority. The philosophy Knudsen proposed was radical by European military standards. Accept adequate performance, standardize designs to enable mass production. Use proven automotive components rather than designing specialized military hardware. Prioritize reliability and maintainability over maximum capability. Build thousands of adequate tanks rather than hundreds of excellent ones. General Wesson, a career artillery officer who understood the mathematics of sustained combat, made a decision that would ultimately determine the outcome of armored warfare in World War II. On August 15, 1940, he approved the development of a medium tank based on Knudsen's philosophy. The design would be simple, reliable, and optimized for mass production. It would use a proven radial aircraft engine, welded rather than cast armor to speed manufacturing, and a medium-velocity 75mm gun adequate for most battlefield targets. The Germans, when they eventually encountered this tank, would name it the Ronson after an American cigarette lighter, because it allegedly lights up the first time, every time. The Americans called it the M4 Sherman. The first M4 Sherman rolled off the production line at the Lima Locomotive Works in Lima, Ohio, on February 12, 1942. It weighed 33.4 tons, mounted a 75mm M3 gun, and was powered by a Wright R975 radial aircraft engine producing 400 horsepower. Maximum armor thickness was 76 meters on the frontal hull. Top speed on roads was approximately 24 miles per hour. The tank required a crew of 5, commander, gunner, loader, driver, and assistant driver, who also operated the hull-mounted machine gun. By European standards, the M4 was unimpressive. German engineers examining captured Shermans in Tunisia in early 1943 found the design almost crude. Oberst Hans von Luck, a Panzer Regiment commander who later published his wartime experiences, described his first encounter with a disabled Sherman in March 1943. "We examined the vehicle with professional curiosity. The armor was adequate, but not exceptional. The gun was respectable, but nothing we feared. The engine, a radial aircraft design, seemed absurdly inefficient for a tank. The suspension was simple, almost primitive compared to German torsion bar systems. The transmission was basic. Everything about the design suggested compromise and simplification. We concluded the Americans had built an adequate tank, nothing more. It would serve well enough against battalion equipment or garrison forces, but in direct combat against German armor, it would prove inferior." Von Luck's assessment was technically accurate. In direct tank-to-tank combat, the M4 Sherman was inferior to Germany's later war designs. The problem was that von Luck, like most German officers, evaluated tanks as individual weapon systems, rather than as components of an industrial production system. While German engineers were correctly identifying the Sherman's technical limitations, American factories were beginning to produce them in quantities that German planners could not comprehend. The transformation of American automotive production into tank manufacturing occurred with stunning speed. The Chrysler Tank Arsenal in Warren, Michigan, broke ground on September 9, 1940. The facility, designed specifically for tank production, covered 113 acres under a single roof. By June 1941, just 9 months later, the first tanks were rolling off assembly lines. By December 1941, when America officially entered the war, Chrysler was producing 300 tanks monthly. By mid-1942, production had increased to 1,000 tanks monthly from this single facility, Ford Motor Company's tank production facility at the Rouge plant in Dearborn, Michigan, applied automotive mass production techniques to Sherman construction. The assembly line moved continuously. Workers installed components at specific stations. Engines, built in a separate area, were lowered into engine compartments in a single operation. Turrets, manufactured at other facilities, were lifted by overhead cranes and mounted on completed hulls. The entire process, from raw steel to completed tank ready for testing, required approximately 6 working days. By late 1942, 11 American factories were producing M4 Shermans. Chrysler Detroit Tank Arsenal 301,000 per month, Fisher Tank Division, Grand Blanc, Michigan. 800 was 200 per month, Ford Motor Company, Rouge Plant. 400, 600 per month, Pacific Car and Foundry, Renton, Washington. 200, 300 per month. Pressed Steel Car Company, Chicago. 400, 500 per month. Baldwin Locomotive Works, Philadelphia. 300, 400 per month. American Locomotive Company, Schenectady, New York. 400, 500 per month. Federal Machine and Welder Company, Warren, Ohio. 300, 350 per month. Lima Locomotive Works, Lima, Ohio. 350, 400 per month. Montreal Locomotive Works, Montreal, Canada. 200, 250 per month. Pullman Standard Car Company, Chicago. 300, 350 per month total. Production capacity by December 1942 exceeded 5,000 M4 Sherman tanks monthly. For comparison, German tank production in all of 1942 totaled approximately 5,800 tanks of all types. Panzer III, Panzer IV, Panzer VI Tiger, and assault guns combined. American industry was producing more Sherman tanks in a single month than Germany produced. Tanks in an entire year. The workers building these tanks represented a demographic transformation of American manufacturing. At the Fisher Tank Division's Grand Blanc plant, employment peaked at 10,427 workers in 1943. Of these, approximately 3,200 were women, representing 31% of the workforce. At the Chrysler Tank Arsenal, women comprised 35% of workers by 1944. These were not traditional female manufacturing jobs in textiles or light assembly. Women welded armor plate, operated machine tools, drove overhead cranes, and performed quality control testing on completed tanks. Rose Monroe, who worked as a riveter at Ford's Willow Run bomber plant before transferring to the Rouge tank assembly line, became the face of Rosie the Riveter propaganda campaigns. But she was one of thousands of women whose labor made American tank production possible. Monroe operated a hydraulic press that formed armor plate sections. Her shift, running from 6 p.m. to 6 a.m., produced approximately 120 armor components nightly. She earned $37.50 weekly, substantially more than typical female employment at the time, and enough to support her 2 daughters while her husband served in the Navy. The quality of tanks produced by this largely untrained workforce initially concerned Army Ordnance officials. Colonel Thomas J. Hayes, stationed at the Detroit Ordnance District Office, ordered comprehensive testing of tanks produced by civilian workers versus those built in traditional armories. His report, dated September 1942, revealed surprising findings. Tanks produced by automotive workers at Chrysler and Ford demonstrate reliability equal to or exceeding tanks built by experienced armory personnel. Failure rates during the first 100 miles of operation show no statistically significant difference between civilian-built and armory-built vehicles. In some measures, specifically engine reliability and transmission durability, civilian-built tanks demonstrate superior performance, likely due to automotive industry expertise and powertrain engineering. Quality control procedures developed by civilian manufacturers prove more systematic, effective than traditional military inspection methods. The standardization that made mass production possible extended beyond individual factories. The M4 Sherman used components manufactured by different suppliers that were fully interchangeable. An engine built in Cleveland could be installed in a tank assembled in Philadelphia. A transmission manufactured in Detroit fit a tank built in California. This interchangeability meant that battlefield maintenance could draw on supply chains from multiple sources, rather than depending on components from a single manufacturer. Technical Sergeant Andrew Miller, a maintenance officer with the 3rd Armored Division, explained the practical impact in a 1943 interview. "We could keep Shermans running with parts scavenged from damaged vehicles. Engine from one tank, transmission from another, final drives from a third. Everything fit. Everything worked together. German tanks, from what prisoners told us, used specialized components. A Tiger tank needed Tiger parts. A Panther needed Panther parts. If a specific part wasn't available, the tank was inoperative. Our Shermans could be rebuilt from whatever we had on hand." The production statistics accumulated through 1942 and 1943 told a story that German intelligence analysts found difficult to believe. American Sherman production by quarter Q1, 1942, 150 tanks. Q2, 1942, 4,200 tanks Q3. 1942, 6,800 tanks Q1. 1942, 8,100 tanks Q1. 1943, 9,300 tanks Q2. 1943, 10,800 tanks Q3. 1943, 11,200 tanks Q4. 1943, 12,100. Tanks by the end of 1943, American factories had produced approximately 54,000 M4 Sherman tanks. For comparison, Germany's total tank production from September 1939 through December 1943, covering the entire first 4 years of the war, totaled approximately 21,000 tanks of all types. The mathematics were becoming clear. Even if German tanks achieved favorable kill ratios in individual engagements, the cumulative production numbers meant that American numerical superiority would eventually become overwhelming. German tank commanders, accustomed to qualitative superiority compensating for a numerical disadvantage, had not yet confronted an enemy that possessed both adequate quality and massive numerical advantage. The first major tank engagement between M4 Shermans and German armor occurred on February 14, 1943, during the Battle of Kasserine Pass in Tunisia. The American forces, primarily elements of the 1st Armored Division, were combat virgins facing German units with years of combat experience. The Germans fielded a mixed force including Panzer III and Panzer IV tanks, along with a small number of the new Panzer VI Tiger-warrant heavy tanks. The engagement was a disaster for American forces. German tanks, using superior tactical positioning and greater crew experience, destroyed 97 American M4 Shermans over 3 days of fighting. American forces retreated approximately 50 miles, leaving behind not just disabled tanks, but also supplies, equipment, and confidence. German commanders claimed a decisive victory and drew conclusions about American armor that would persist through the war. General Heinz Guderian, Inspector General of Armored Troops and the father of German Blitzkrieg doctrine, received detailed after-action reports from Tunisia. His assessment, circulated through German High Command in March 1943, demonstrated the dangerous overconfidence that would characterize German analysis of American armor. The American M4 tank represents adequate engineering for a nation without armor tradition. The 75mm gun has reasonable penetration against medium armor, but proves ineffective against our Tigers. Armor protection is mediocre, barely sufficient against our 75mm weapons, and completely inadequate against 80mm guns. The radial aircraft engine is inefficient and prone to fire when penetrated. American crews demonstrate poor tactical skills and retreat when confronted by determined opposition. The concerning factor is not tank quality, but quantity. American production exceeds rational military requirements. They build tanks as they build automobiles, in vast numbers without regard for resource efficiency. However, numerical superiority cannot compensate for technological inferiority and tactical incompetence. 10 poor tanks do not equal 1 excellent tank if the excellent tank destroys enemy vehicles before they can bring numerical advantage to bear. Guderian's analysis represented conventional German military thinking, quality over quantity, technical excellence over industrial mass production. German tank development philosophy emphasized superior armor protection, more powerful guns, sophisticated engineering, and crew training that required years to complete. The Tiger II, entering service in late 1942, embodied this philosophy. Weighing 54 tons with frontal armor up to 120 millimeters thick and mounting the feared 80mm KWK-36 gun, the Tiger could destroy Allied tanks at ranges exceeding 1,500 meters, while remaining invulnerable to most Allied weapons. SS Hauptsturmführer Michael Wittmann, who would become Germany's highest-scoring tank ace with 138 confirmed tank kills, encountered his first Shermans in Normandy in June 1944. His post-action report, discovered in German military archives in the 1960s, revealed the contempt many German tank commanders felt toward American armor. The Sherman is a death trap for its crew. Our 88mm penetrates its armor with ease at any range. The ammunition storage, positioned in hull sponsons, causes catastrophic fires when penetrated. American crews abandon vehicles after a single hit, which is tactically sound as a second hit typically ignites fuel and ammunition, destroying the tank completely. The Sherman's 75mm gun cannot penetrate Tiger frontal armor even at point-blank range. American crews attempt to flank our positions, but their tactical movements are clumsy and easily countered. I estimate each Tiger equals 5 to 7 Shermans in combat effectiveness. At current engagement ratios, German armor superiority remains decisive. Wittmann's assessment was technically accurate. In direct combat at typical engagement ranges, a German Tiger or Panther tank could destroy an M4 Sherman before the Sherman's gun could penetrate German frontal armor. Battle statistics from Normandy appeared to validate German superiority. At Villers-Bocage on June 13, 1944, Wittmann's single Tiger tank destroyed 14 British tanks, 15 personnel carriers, and 2 anti-tank guns in approximately 15 minutes, forcing an entire British armored column to retreat. German newsreels from 1943 and 1944 featured footage of destroyed American Shermans burning in French fields. The propaganda ministry used these images to assure German civilians that despite Allied bombing and Eastern Front retreats, German armor remained superior to anything the Americans could build. Wehrmacht briefing materials emphasized favorable kill ratios. German tanks destroying 3, 4, sometimes 5 American tanks before being knocked out themselves. What German analysts consistently failed to understand was that kill ratios, while tactically important, were strategically irrelevant when confronted with overwhelming industrial production. General der Panzertruppe Friedrich von Mellenthin, who served as chief of staff for several panzer armies, later wrote in his post-war memoir published in 1956, "We were winning tactical victories while losing the strategic war. Every tank we destroyed was replaced by 3 more. Every crew we killed was replaced by better trained crews. We calculated based on European industrial capacity, where destroying 100 enemy tanks represented a significant reduction in combat power. The Americans simply built another 300 tanks the following month. Our tactical excellence became strategically meaningless against such numerical superiority." The production numbers tell the story that German field commanders did not fully grasp during combat operations. In 1943, Germany produced approximately 5,800 tanks total. The United States produced 29,497 M4 Shermans plus 5,796 M3 or M5 light tanks, 35,293 tanks total. In 1944, as German production strained to replace losses on multiple fronts, Germany managed to produce approximately 9,000 tanks, including Panthers, Tigers, and assault guns. American production that same year, 17 F565 M4, Shermans plus 4,070 light tanks, 21,135 tanks total. The cumulative impact of sustained high-volume production meant that by mid-1944, American forces in Europe possessed overwhelming armor superiority despite inferior individual tank characteristics. The 2nd Armored Division landed in Normandy with 186 M4 Shermans. The 3rd Armored Division fielded 232 Shermans. The British fielded hundreds more Shermans received through Lend-Lease. German panzer divisions in Normandy, by comparison, typically fielded 80, 120 tanks of all types, and those numbers declined rapidly as combat losses exceeded replacement capacity. Oberstleutnant Hans von Luck, commanding a panzer regiment in Normandy, described the growing realization among German commanders. By June 1944, we understood intellectually that Americans possessed numerical superiority. What we failed to grasp emotionally was the sheer scale of that superiority. We would destroy 5 American tanks in a morning engagement, consider it a successful action, then face 15 American tanks in the afternoon at the same position. We inflicted casualties that would have crippled any European army, but the Americans simply absorbed losses and continued advancing. It was like fighting an endless wave. No matter how many you destroyed, more appeared. The German mockery of American tanks, so prevalent in 1942 and 1943, began transforming into concerned recognition by late 1944. But recognition came too late to alter strategic outcomes. The industrial mathematics could not be changed by battlefield tactics. August 8, 1944. The Falaise Pocket, Normandy, France. German forces trapped between American, British, and Canadian armies fought desperately to escape encirclement. The 2nd Panzer Division, once an elite formation with approximately 120 tanks, had been reduced to 31 operational vehicles after 6 weeks of continuous combat. American and British forces pressing the pocket from multiple directions included over 600 Sherman tanks from 5 armored divisions. The arithmetic was simple and devastating. For every German tank destroyed, American forces could replace losses within days from the massive logistics infrastructure supporting Allied operations. For every German tank destroyed, German forces struggled to bring forward replacements from production facilities in Germany under constant Allied air attack. The battle statistics from the Normandy campaign reveal the cumulative impact of industrial superiority overwhelming tactical excellence. From From June 6th to August 25th, 1944, Allied forces in Normandy lost approximately 2,500 tanks, the majority being M4 Shermans. German forces lost approximately 1,300 tanks of all types. In terms of exchange ratios, the Germans performed credibly, roughly 1-to-1 losses, despite facing significant numerical disadvantage. But replacement capacity determined strategic outcomes, not battlefield exchange ratios. Allied forces received approximately 1,700 replacement tanks during this period, restoring and even expanding their armor strength. German forces received fewer than 200 replacement tanks, gradually bleeding their armored formations toward destruction. By late August, German panzer divisions that entered Normandy with 100-plus tanks fielded 10-20 operational vehicles. American armored divisions that landed with similar strength maintained 150 to 200 operational tanks despite continuous combat. The logistics infrastructure supporting American armor operations represented industrial capacity that Germany could not match. The Red Ball Express, a dedicated truck convoy system running supplies from Normandy beaches to forward units, transported approximately 12,500 tons of supplies daily at peak operation. American armored divisions consumed approximately 350,000 gallons of fuel per day during active operations. Ammunition, spare parts, replacement engines, and entire replacement tanks flowed forward continuously. Colonel James Burt, commanding Combat Command B of the 3rd Armored Division, described the practical impact. We could afford to take losses that would paralyze German operations. I lost 30 tanks in 3 days, fighting near Mortain. Within a week, I had 35 replacement Shermans, fresh crews, and full ammunition loads. The Germans lost 20 tanks in the same engagement. As far as we could tell, they received no replacements. We got stronger. They got weaker. The mathematics were inevitable. And the production and deployment statistics from 1944 demonstrate how American industry translated factory output into battlefield superiority. Total M4 Sherman production in 1944, 17,565 tanks. Tanks shipped to European theater, approximately 9,200. Tanks shipped to Pacific Theater, approximately 2,800. Tanks retained for training and domestic defense. Approximately 5,500 of the 9,200 Shermans shipped to Europe. Approximately 4,500 were replacement vehicles sent to replace combat losses. The U.S. Army's replacement system maintained a pipeline of tanks, spare parts, and trained crews that kept armored divisions operational despite casualties that would have destroyed European armies. German tank production in 1944 faced challenges that American factories never experienced. Allied strategic bombing, while less effective against German industrial capacity than post-war analysis initially claimed, created persistent disruptions. Ball-bearing factories, essential for tank production, were repeatedly bombed. Transportation infrastructure, rail yards, bridges, marshalling points suffered continuous attacks that delayed tank movements from factories to combat units. The German Ministry of Armaments, under Albert Speer's direction, achieved remarkable production increases despite Allied bombing. German tank production in 1944 reached approximately 9,000 vehicles, nearly double 1943 production. But these increases came at tremendous cost. Labor was diverted from other critical industries. Raw materials became scarce as Allied advances cut off resources. Quality control suffered as inexperienced workers replaced skilled craftsmen called to military service. Moreover, German production dispersed across multiple designs rather than standardizing on a single platform. In 1944, German factories produced Panzer IV, medium tanks, approximately 3,200. Panther medium tanks, approximately 3,800. Tiger were heavy tanks, approximately 450. Tiger II heavy tanks, approximately 380. Assault guns, Stu G3, Stug IV, Jagdpanzer IV, approximately 2,200. Each design required unique parts, training, maintenance procedures. A Tiger transmission could not fit a Panther. Panther parts could not repair a Panzer IV. This diversity, while providing tactical flexibility, created logistics nightmares. German maintenance units required multiple parts inventories. Repair facilities needed specialized knowledge for each design. Training programs consumed time teaching crews multiple vehicle systems. American standardization on the M4 Sherman meant that every tank used interchangeable parts. Every crew trained on the same systems. Every maintenance officer knew Sherman mechanical systems intimately. Every supply depot stocked identical spare parts applicable to any Sherman variant. The industrial efficiency of standardization multiplied American numerical advantages. The combat mathematics became increasingly unfavorable for German forces through late 1944. The Battle of Arcourt in September 1944 demonstrated the cumulative impact of American armor superiority. The 4th Armored Division, with approximately 200 M4 Shermans, engaged the German 5th Panzer Army's armored elements, which included approximately 150 tanks of mixed types, including Panthers. The Americans lost 31 tanks destroyed. The Germans lost 86 tanks destroyed. But the Americans received 35 replacement tanks within a week. The Germans received 12 replacements over 3 weeks. By December 1944, American forces in Europe fielded approximately 1/600 in M4 Shermans in combat divisions, plus another 900 in the replacement pipeline. German panzer forces in the West totaled approximately 800 operational tanks of all types. The numerical advantage exceeded 2-1 before considering the industrial capacity to replace losses. General George Patton, commanding 3rd Army and one of America's most aggressive armor commanders, understood that the Sherman's technical limitations were irrelevant given numerical superiority. His diary entry from October 1944, declassified in 1974, captured American strategic thinking. The Sherman is not the best tank on the battlefield. The German Panther is superior in armor and gunpowder. But we have 10 Shermans for every Panther, and that ratio increases every week. I can afford to lose 3 Shermans, destroying 1 Panther, and still come out ahead. The Germans cannot. They mock our tanks as inferior. They fail to understand that adequate multiplied by overwhelming numbers defeats excellent multiplied by inadequate numbers. This is a war of production as much as a war of combat. December 16th, 1944. The Ardennes offensive, Hitler's final gamble to split Allied armies and force a negotiated peace, began with initial success. German forces achieved tactical surprise, overwhelmed American positions, and advanced 50 miles in the first week. Kampfgruppe. Piper's Tigers and Panthers destroyed American forces that attempted to stand and fight. Traditional German armor doctrine appeared vindicated. Then the American industrial machine responded. Within 48 hours of the German breakthrough, American armored divisions hundreds of miles distant received movement orders. The 2nd Armored Division, resting in Belgium after months of continuous combat, began moving south on December 17th with 186 operational Shermans. The 3rd Armored Division moved from positions near Aachen with 221 Shermans. The 4th Armored Division, part of Patton's 3rd Army, executed a 90-degree pivot from eastward advance to northern movement, bringing 187 Shermans into the battle. By December 22nd, American forces had concentrated approximately 600 M4 Sherman tanks against the German penetration. Additional armor continued arriving daily. The Germans, by comparison, had committed approximately 400 tanks to the offensive, Panthers, Tigers, and Panzerfuhrs. These represented a significant portion of Germany's entire armor reserve in the West. The battle that followed demonstrated how American industrial capacity had transformed battlefield dynamics. German tanks individually outperformed Shermans. Kill ratios favored German crews, but American forces simply absorbed losses and maintained offensive pressure. When a Sherman platoon of 5 tanks encountered a German position, 1 or 2 Shermans might be destroyed. But the remaining tanks would flank, suppress, and eventually overwhelm the German position through combined arms tactics supported by overwhelming artillery and air support. SAS Obersturmbannführer Jochen Peiper, whose Kampfgruppe had spearheaded the German advance, found himself surrounded at Stoumont by late December. His after-action report, captured when he surrendered in 1945, revealed the psychological impact of facing American armor superiority. We destroyed American tanks continuously. Our guns were superior, our crews more experienced, our tanks better protected, yet they kept coming. We would knock out 5 Shermans in a morning engagement. By afternoon, 10 more appeared. We destroyed those. The next morning, 15 more arrived. They absorbed losses that would annihilate any German formation and simply continued attacking. The American tactical approach was crude, mass formation attacks with little finesse. But finesse becomes irrelevant when facing such numerical superiority. We fought well. We inflicted disproportionate casualties. And we lost because the Americans possessed unlimited replacements while we had none. This was not a battle. It was industrial suffocation. By early January 1945, the Ardennes offensive had failed. German armored losses exceeded 600 tanks, virtually irreplaceable given German industrial capacity and raw material shortages. American losses exceeded 700 M4 Shermans, but within 3 weeks, all were replaced. and American armored divisions stood stronger than before the offensive. The psychological transformation among German commanders was profound. General der Panzertruppe Hasso von Manteuffel, commanding 5th Panzer Army during the Ardennes, later wrote in his post-war interrogation, "We entered the Ardennes believing we could achieve decisive victory through superior tactics and equipment. We exited the Ardennes understanding that wars are won in factories, not battlefields. American industrial capacity rendered German tactical excellence strategically meaningless. Every tank we destroyed was replaced. Every crew we killed was replaced. Every position we overran was retaken. We could not win because we could not replace losses faster than the Americans inflicted them." The statistical reality supported von Manteuffel's conclusion. From D-Day through May 1945, American forces in Europe lost approximately 7,000 M4 Sherman tanks to all causes: combat, breakdown, accidents. Over the same period, American factories produced approximately 15,000 new Shermans and shipped approximately 9,000 to European theater operations. German forces destroyed more American tanks than existed in American formations on D-Day. Yet American armor strength increased continuously throughout the campaign. The mathematics of replacement capacity determined the war's outcome as much as battlefield tactics. An American armored division losing 50 tanks in a month of combat received 60 replacement tanks and emerged stronger. A German panzer division losing 50 tanks in a month received 15 replacements and gradually declined toward combat ineffectiveness. By March 1945, as Allied forces crossed the Rhine and penetrated into Germany proper, the armor imbalance had become absolute. American forces fielded approximately 2,000 M4 Shermans in combat divisions. German panzer forces totaled fewer than 400 operational tanks of all types. The vaunted Panther and Tiger tanks that had terrorized Allied crews in 1943 and 1944 now sat abandoned along roadsides, out of fuel or broken down with no spare parts available for repair. Oberst Hans von Luck, surrendering his regiment in April 1945, reflected on the transformation in German thinking about American armor. In 1942, we mocked American tanks as crude and inferior. By 1945, we feared American tank formations, not because individual tanks were superior, but because there were always more of them. We could not destroy them faster than they were replaced. This was a new kind of warfare, industrial attrition on a scale European armies had never experienced. The Americans won not through tactical brilliance, but through overwhelming industrial capacity applied systematically and ruthlessly. The final production statistics told the complete story. From 1942 through 1945, American factories produced 49,234 M4 Sherman tanks. Germany produced approximately 23,000 tanks of all types during the same period. The United States produced more than twice as many tanks as Germany, while simultaneously producing the world's largest navy, the world's largest air force, and serving as the primary supplier of equipment to Britain, Soviet Union, and other Allied nations through Lend-Lease. The Sherman, mocked by German commanders as inferior, became the most widely produced tank in history and served with 17 different Allied nations. While German Tigers and Panthers collected mythology as the ultimate tanks, Shermans won the war through simple mathematics, adequate quality, absolute reliability, overwhelming quantity. The M4 Sherman served with the U.S. Army through the Korean War and remained in service with various nations into the 1970s, nearly 30 years after the first production vehicle. Surplus Shermans equipped the Israeli Defense Forces during the 1948 Arab-Israeli War and subsequent conflicts. Modified Shermans with upgraded guns served in Israeli service until the late 1970s. Argentina, Chile, and Paraguay operated Shermans until the 1990s. More than 50 years after initial production, the tank that German commanders mocked in 1942 outlasted every German tank design by decades. Tigers and Panthers, celebrated for their technical sophistication, proved too complex for sustained operation. Most surviving examples sit in museums, mechanically inoperative due to parts unavailability and maintenance complexity. Shermans, by contrast, remain operational in private collections and military museums worldwide. The Bovington Tank Museum in England regularly demonstrates a running Sherman. Private collectors routinely drive Shermans in historical reenactments. The industrial philosophy that created the Sherman influenced American military procurement for decades. The principle of adequate quality, overwhelming quantity became doctrine for successive generations of American weapon systems. The M16 rifle, built in millions rather than seeking perfection. The F-16 fighter, designed for mass production rather than maximum capability. The Abrams tank, standardized across multiple variants to enable efficient production and maintenance. Professor Richard Overy, examining Allied victory in his comprehensive study published in 1995, identified the Sherman production program as emblematic of American industrial warfare. The Sherman represented American industrial philosophy applied to military hardware. It was not the best tank, but it was good enough, and America built 50,000 of them. The Germans built better tanks, but fewer than 25,000 total. The mathematics were simple: adequate multiplied by overwhelming equal superiority. The Sherman proved that industrial capacity matters more than individual weapon. Excellence, when that capacity can sustain continuous replacement of combat. Losses. The workers who built Shermans, the women who welded armor, the former farmers who operated presses, the housewives who assembled engines, carried forward the lessons of wartime production into peacetime careers. The training programs that taught tank assembly in weeks rather than years influenced post-war vocational education. The quality control systems developed to ensure tank reliability became standards in automotive and aerospace manufacturing. The facilities that built Shermans continued influencing American industry for decades. The Chrysler Tank Arsenal in Warren, Michigan produced M48 and M60 tanks through the 1970s, then M1 Abrams tanks from 1980 onward. The Detroit Arsenal tank plant remains operational as of 2024, continuing the tank production tradition that began with M4 Shermans in 1941. The strategic impact of Sherman production extended beyond American forces. Through Lend-Lease, the United States supplied 102 M4 Shermans to the Soviet Union, where they equipped entire tank brigades fighting on the Eastern Front. British and Commonwealth forces received over 17,000 Shermans, equipping the majority of British armored divisions from 1942 through 1945. Free French forces, reconstituted after liberation, fielded Sherman-equipped armored divisions that fought through France and into Germany. The cumulative impact of Sherman production on Allied victory cannot be overstated. The tank enabled the mobile warfare that characterized Allied operations from 1943 onward. It provided the armored forces that broke out of Normandy, raced across France, and penetrated into Germany. It equipped the divisions that fought through Italy, southern France, and ultimately occupied post-war Germany and Japan. General Dwight Eisenhower, Supreme Allied Commander in Europe, reflected on American armor in his post-war memoir published in 1948. The Sherman tank was not superior to German armor in direct combat, but the Sherman was reliable, maintainable, and available in unlimited quantities. We could replace losses faster than the Germans could inflict them. This ultimately mattered more than individual tank performance. Wars are won by the side that can sustain combat operations longer than the enemy. The Sherman and the industrial system that produced it in such numbers gave us that sustainability. The German High Command's failure to understand American industrial philosophy cost them the war as surely as battlefield defeats. They evaluated tanks as weapon systems rather than as products of industrial capacity. They prioritized technical excellence over production efficiency. They assumed that quality would triumph over quantity when given adequate tactical leadership. They were wrong. The Americans proved that adequate quality, produced in overwhelming quantity with efficient logistics and systematic training, defeats technical excellence produced in limited numbers. The M4 Sherman, mocked by German tank commanders as inferior, became the most produced tank in history and the vehicle that carried Allied forces to victory. The story of how 50,000 adequate tanks defeated Germany's technically superior armor is ultimately a story about industrial philosophy. It demonstrates that modern warfare is won in factories as much as on battlefields. It proves that sustainable production matters more than individual weapon. Superiority when production capacity can maintain continuous operations despite losses. The Germans built the Tiger, a masterpiece of armored engineering that cost 800,000 man-hours to produce, required specialized maintenance, and could not be adequately supplied with spare parts. The Americans built the Sherman, a reliable, standardized tank that cost 7,000 man-hours to produce, could be maintained by crews with minimal training, and was supplied in unlimited quantities through efficient logistics. The Tiger became a legend. The Sherman won the war. German tank commanders mocked the M4 Sherman from 1942 through early 1945, right up until the moment they surrendered to crews driving those same inferior tanks. The mockery stopped when German panzer divisions, once the terror of Europe, sat immobilized for lack of fuel, ammunition, and replacement vehicles, while American armored divisions rolled past in endless columns. 50,000 Shermans proved that wars are not won by the best weapons, but by adequate weapons produced in overwhelming numbers and sustained by industrial systems capable of replacing losses faster than the enemy can inflict them. The Germans learned this lesson too late to change the outcome. They mocked American tanks until American tanks were the only tanks still running.